Hello and welcome to this episode of T-Tech. This is part 2 of 3 in our series to configure FreeBSD as a firewall. So in this part we are going to tweak all the configuration settings and turn all the knobs to make FreeBSD function as a firewall. So to begin with, we're going to run ifconfig, and what I want to talk about is EM0 here. That interface corresponds to our LAN network from our diagram, whereas EM1 corresponds to our WAN. Now, we're going to configure those IP addresses on the interfaces first. We configure these with vi, which is a text editor, and this is in etc rc.conf. Hit enter. And in this file, we're going to go to the last line and just tap O, and that will open a new line underneath it. Now we're in edit mode. We are going to type ifconfig underscore EM0 and equals, and now we're going to have a quote. And this portion we're going to set the IP address. So we're going to do init for an IPv4 address. It's 192.168.1.1 with the net mask of 255.255.255.0. And we want to wrap all this in with quotes as well. Now, the network mask, since IPv4 addresses are represented by 32 bits, so 32 binary bits, so ones and zeros, each octet of this address, so like the 192 is 8 bits, the 168 is another 8 bits. The net mask takes those 32 bits and divides them up into two portions, the network and host. The network portion is much like the street. Okay, the host portion is a lot like the houses on the street. So essentially, the 255 means all the bits are on. So in this case, in the first, second, and third octet, they are all on. So that means we can't change those at all. So what identifies the network portion here is 192.168.1. As long as the first 3 octets are 192.168.1, we are in that network. As soon as we want to go to a network that doesn't start with the same first 3 octets, that's when the firewall gets involved. So that I wanted to explain that so it makes a little more sense of how and why we use the firewall like that. So now we want to configure our WAN interface. We're going to do that with ifconfig underscore EM1. And if you're on a cable modem or DSL modem or any other type of modem you can think of, satellite, fiber, any of them, basically there's 2 ways that we can get an internet connection, either dynamically with DHCP or statically. We're going to show how to get the dynamic one. All we would have to do is type DHCP, and that will automatically get the addressing information for us. But in our case, we had a static address in the diagram, so we're going to go ahead and put that in. So init space 192.168.0.25, and then the net mask of /24. Alright, now on your WAN, when you set a static IP address, you also have to set a default gateway. Now normally with DHCP, that is automatically taken care of for us, but we need to set one here. So default router equals 192.168.0.2 in my case, and then if it was a public IP, it would be whatever public IP they gave you. Now we're going to enable IP routing. To do that, we're going to type gateway underscore enable equals, and then in quotes, type yes as all caps, and that enables it to take that packet and do the destination address lookup and route it. After that, we need to set up PF, which stands for packet filter. That's the firewall in FreeBSD. So we're going to do PF underscore enable equals, then again, capital yes. That enables it. And we're going to do pf_rules equals /etc/pf.conf. Alright. Now, a quick side note, so there's no confusion. The PF I'm talking about here is actually an older version of PF from OpenBSD. So PF originated in OpenBSD and then was ported to FreeBSD. But now the two versions of PF have diverged quite significantly between FreeBSD and OpenBSD. So it started in OpenBSD but then went to FreeBSD. So just so you don't get confused if you're looking up OpenBSD stuff and see references to PF. So now that we've specified our config file where our rule set is, we want to hit escape to get out of edit mode and hit our shift key and tap the Z key twice. That will save our file. And we need to set up the rule set now. So vi/etc pf.conf. And first thing we're going to do is set up some macros. Now, the macros simply hold any kind of information like an interface name or an IP address. We take that and assign that to a macro, and then we can refer to that macro in any rule in our rule set. First one I'm going to type is LAN equals, then in quotes we're going to type EM0, so that corresponds to our LAN interface. And now I'm going to type WAN equals EM1, that corresponds to our WAN, of course. Now down here we're going to set skip on LO0. Now the LO0 is the loopback interface. It's usually just used for testing, and there's other advanced uses for it, like your router IDs in OSPF. But we're not going to worry about those here. All we have to know for this is the set skip just tells PF to not filter on that interface, so all packets will be let through. Now we're going to go and set block-policy drop. This tells PF what it should do when it sees drop in a rule. Now there's two ways it can go about this. There is return and drop. Now return set basically if a packet comes in and it's destined to a port that doesn't have anything listening on it or is not open, in other words, is being blocked, it will actually send information back. So for instance, if it was a TCP packet, we would send a reset acknowledgement back to the sender that sent the packet. The problem with this is that tools like Nmap can use this information that comes back to discern if a port is really closed or open. So if we don't send anything, it doesn't know. So that is why we set that to drop, so when we plug this into the internet and it's getting scanned, those packets won't have any, replies sent to them, and we're exposing less attack surface that way. Now, PF processes packets from top to bottom, and the last rule that matches is the action that PF will take on that packet. Essentially, the packet will come in and it will be evaluated by the rule set, and that block and pass value can be switched on the packet, over and over till the end of the rule set. That does mean, though, that if we put our rules in the wrong order, the packets can inadvertently be dropped. But before we actually get to our rules there, we want to start with that NAT, that network address translation. We want to do NAT on. And we're going to use our $WAN, so our WAN interface is going to do the NAT. And it's going to say from $LAN:network. Now, the cool thing about doing the LAN:network is it maps dynamically to whatever is assigned to EM0 as far as whatever network is. So if we change the interfaces or the network, we don't have to rewrite the RPF-conf file. It just automatically adjusts. Okay, so that has to be going to any destination to match, and then to tell it what source address to use to replace the source address of these packets, we're going to say hyphen, have a bracket, space, and then in parentheses, we're going to say $WAN, and then close the parentheses. This allows PF to change the source address to the 192.168.0.25 in our case when it goes out of the firewall. And the parentheses are great if we use DHCP and the address we lease has changed. So then we don't have to reload the file, it just keeps routing. So now below that, our first rule is going to be block drop all. Now if we don't add anything else, the last match rule will always be this block rule. So everything will be dropped. The block drop all does what it says. It's going to block packets from any source address, any destination address, any port, any protocol. Everything is just going to be dropped completely. So, under that though, we're going to pass our LAN traffic in. So we're going to say pass in on our LAN interface, and hopefully we're getting the hang of this, that we're using the macros like this now. So that's going to be in our LAN interface from our LAN network, see, alright, to any destination, and now we're going to keep state. Now the keep state is a crucial concept in PF. By putting keep state there, it tells PF that any packets that match this rule will go into the state, so we know that they belong to that connection. So then when the return packets come back for the connection, PF can just look in its state table instead of having to reevaluate its rule set. And that is actually much quicker than having to send the packet down the rules every time. But that is what the keep state is doing for us, and it's keeping that security. So if it comes back and it's malicious for some reason, or it's not expected, it's going to drop it. And it's going to hit the block drop rule, because it's not going to match this rule. So, now we want to route that traffic out to the internet, so pass out on our WAN from our LAN network to any destination, and again, we want to keep the state. So we're keeping state on both sides of the firewall. Now, lastly, we want to put in a rule to allow the firewall itself to talk. So we can do pings and updates and things like that. So we're going to say pass out on WAN from WAN network to any destination, and keep state for the same reason. So this is how we set up our PF-conf to allow the LAN to be able to get into the firewall and route it out to the WAN, and to allow the firewall to talk out to the internet. Now, you will notice there's no pass-in rule for the WAN itself. What that means is the only traffic that will be able to come in on the WAN interface is traffic that matches a state, which is only going to be created for the LAN, at least, if a packet matches the LAN. It's going to create state, then it's going to go out the WAN and create another state, and that will allow that traffic to come back in. But otherwise it will be dropped though if it's not in the state table. So that's the great thing about that. We're going to hit Shift and Z again, double Z to save it again. And now we are going to have to bring up our interfaces at this point. So we're going to do /etc rc.d netif start. Now you could also reboot at this point as well, but that will bring up our interfaces. And you see EM0 has our LAN address, and EM1 has the WAN address. Okay. At this point, we should also always check, make sure the default gateway is set. And as you can see, it is not set, so we do have to go into etcrcd again, routing, start, and that adds our default gateway. Again, you could just reboot, and that would be fine too. We'll do a quick test ping, and we have connectivity. So now we have to install DHCPD, which is the DHCP server that will automatically hand out IP addresses to our LAN side with all our LAN devices on it. So we're going to do package to do that. And we actually, because this is a stock install, we do have to install it, the package management tool, initially. And after that is installed, we're going to do package update, and this gets the repository information for the installable packages that are available. And that extracts it out so we are able to use them. And after this is done, we'll be able to search through this. So we're going to search with package search ISC-DHCP-server. I'm sorry, actually, just let's do ISC DHCP. There we go. And we want to install the ISC DHCP 44-server. So to do that, we're going to do package install ISC-DHCP 44-server. We'll say yes to it. And now the server is installed. So the first thing I'd recommend doing is actually going back in to etcrc.conf with vi, and we'll go ahead and enable the DHCP server on boot. We want to type DHCPD_enable equals yes in all caps, and save that again with Shift-ZZ. Now we want to actually edit the config file for DHCP a little bit. So we're going to vi user local etc dhcpd.conf. And now, first thing we're going to do is change the domain name. This is the domain name for the local subnet. So what we're going to do is change it to TTEC in this case. Just as long as it's something you know what it is and it's valid in your environment, it will work fine. Now, we're going to change our domain name servers as well. These are what we hand out to clients so they can resolve IP addresses. Resolve domain names into IP addresses. In this case, I'll use 4.2.2.1. And my second one to assign to my clients as a backup will be 4.2.2.2. Now, you can use any valid public ones you want, but those are the ones I'm using here. We'll keep all of the least times and everything their defaults. We want to go down here and we'll hit the O key. And now we need to tell the DHCP server what subnet it should listen on. We're going to say subnet. Now this will be our LAN subnet. So 192.168.1.0. And now we're going to do net mask. This should look very familiar from the rc.conf file. So a /24 network mask again. Opening curly brace to start this block. And we're going to enter down twice. And tab in, and we're going to type range. This tells the DHCP server what addresses within this subnet that it's allowed to lease out to clients. Ours will be 192.168.100 through 192.168.1.200. End it with a semicolon, and enter down and tab over, and we'll say option routers space 192.168.1.1, and end that with a semicolon. The option routers is specifying the default gateway we're going to give our clients on our LAN side. So this has to be the LAN IP address, okay, of EM0 in our case. So we'll tab down here and wrap all this in another curly brace, and that is our subnet block. So we'll hit escape and Shift-ZZ again. Now before we get ready to reboot this server, we do want to test the file. So we want to use DHCPD-T to do that. And the config file is loaded, the one we just edited, the user local /etc dhcpd.conf, and that means it's valid and ready to go. at this point, if there was an error, it would show you, and you can go in and fix it at that point. Most common error I have done personally is missing semicolons or mistyping an IP address. So be careful about that. But, excuse me. Okay. Now, there's a few more housekeeping things I want to do in the rcconf file. Essentially, I want to enable automatic time, so network time protocol. We're going to use NTP date to do this, and we're going to say enable. So NTP date _ enable equals yes in all capitals, and we're going to specify what pool of servers we want to use with NTP date _ flags equals north-america.ntp pool.org in my case. Now, if you need other servers for the country you're in, just go ahead and search NTP pool servers, and you'll be able to find a list from there. Now, last two things we're going to do is sendmail _ enable equals none. So we want to disable the SMTP server completely. Okay. And we also want to do syslogd _ flags equals -ss. This disables the UDP port that is for remote logging with syslog. We don't need any remote logging to this system, so it's safe to disable that. Alright, now if you actually want to go ahead and disable those two pieces of software without rebooting, you can just do etc rc.d sendmail stop, and you can do etc rc.d syslogd restart. Okay, and now there should be, oops. Okay, there we go. Now there's no listening port though, so that is what we wanted. So now all we gotta do is quick reboot the server and we'll verify a few things. So I will see you in a second. Okay, welcome back. We're back up and running. So we're gonna log in as root, and we're gonna do ifconfig real quick. EM0, we're gonna want to check the init line. It is the correct IP and mask. Same thing for EM1. Make sure it has the correct IP we configured, and it does in this case. So to check PF, we're gonna do pfctl -sr to show our rules, and all of our rules are loaded, and the syntax we had with $LAN:network and things like that has resolved. Let's check our NAT with pfctl-sn. That's great too. Let's check our connectivity as well with a ping. We're all good there. Let's check that we have a default gateway, and obviously we do. Great. And we'll do sysctl-a, and we're going to pipe that output to the input of grep to search for some text, -i for case insensitivity, and we're going to do forward. And again, net IP forwarding is set to 1 because of the gateway _ enabled equals yes inside of the etc rc.conf file. So that verifies our interfaces, PF, and our IP routing. One more thing with PF as well. I recommend though that you verify the config file. So do pfctl -nf and do etc pfconf. And if there's no output, we are all good to go. That just makes sure there's no errors. You'll need that in the future if you're making changes to it and allowing ports and doing port forwards and things. That comes in a lot of handy. So other than that, we'll do one more verification of DHCPD. We're going to run top to do that. And DHCPD is running, and we'll also verify it with netstat-an. And down here, port 67 is running, which is the UDP port for the DHCP server. So this is, with all of that, that is how we set up our firewall in FreeBSD, and we've set it up the LAN interfaces, the DHCP, the routing, and the firewalling. So with all that, this is part 2 of 3, and I'm Tyler with T-Tech, and I'll see you in part 3, and thank you for viewing. Have a nice day.